Good evening, my esteemed audience and participants in this training. This is video 3, still on the topic Python application to Markov chain prediction for forex markets, Nigerian foreign market specifically. So we are dealing with Naira dollar exchange rate. In my previous videos on this subject matter, I treat the rudiments of Markov chain. That is the first video. The conceptual definition, the assumptions, and the type. Then in the second video on this subject matter, I treated the Python application with respect to building a Markov, building a transition matrix for the Markov chain prediction, the state ahead prediction, and then the heat map, the bar chart to visualize the forecast. These were done in the second video. Now, in this third video, I would like to treat very few things also. The first thing that we are going to plot is the network, the state transition network. Thereafter, we look at the stacked area plot of forecast. The stacked area plot of forecast. And then histogram of observed price states. Histogram, look at the histogram. Then next to that is the step-by-step chord diagram code with plot3. Then next to that is complete Python code to group price band for better readability, calculate transition between group bands, extract the top 10 most frequent transition, and then plot two sacking diagram side by side to compare pre-2025 and 2025 onward trend. Chord diagram, sacking view of price band transition. Then line plots comparing actual versus most likely predicted paths. Then log run steady state Markov chain forecast, the log run Markov chain stimulation, short-term Markov state stimulation. These are the things we are going to do. I will skip this ones. Let me name those ones I will skip here. I will skip number 8. The chord diagram. I also skip the complete code for that chord diagram to group the price to bands for better readability. Then I also skip number 10 chord diagram circuit view of price band transition. I will skip them. If you are interested in these ones that I said I will skip, you can send me a WhatsApp message on my WhatsApp line, which is 08060962048. I repeat, my WhatsApp line is 08060962048, or send me an email message. My former email address is ajibola.arewa@laxu.edu.ng. ajibola.arewa@lasu.edu.ng. ajibola.arewa@lasu.edu.ng. Now, those ones that I will do, let's start with them. The first one is this number this number 5, the state transition graph, that is the directed network. Now, how do we do that? We need to get the code from ChatGPT as usual, and then execute it in Python to draw the network. So what we do is just to say that give me the Python code. Let me put that. Give me the Python code. If you like, you put that. Give me the Python code. So let me quickly do that. Let's look at the network. So you go to chat to now enter. Yes, I think chat is bringing out the code. Yes, let me see what is here. Now, there's something we do first. It's a Python code to plot the state transition graph. Make sure you have network and then matplots. So we have to install that first. If this is not installed, Python may not be able to plot it. So we have to go to an Okanda prompt to install this. We copy, we go to the prompts. And that is why if you listen or watch my video too, I said as you are opening the Jupyter notebook, also open the Anokata prompt. So let's paste it there. So if you don't put that code here, it may not run in notebook. So let's go back to the notebook. Go back to the notebook. So we can now use the complete code now. Since we have installed this, we can now use the complete code. Now I copy. So let me go back to Python notebook to execute. Yeah, enter. Yes, this is it. This is a network. Now, in this network, we have the probability of staying in the same beam, in the same loop, in the same state, and then the probability of transiting between beam or between states or between bounds. You know, if you listen to my previous video, the videos are interconnected. If you really want to understand what I'm doing, you have to start from video 1, from video 1 to video 2. This is now video 3. So these cycles are the bounds. These ovals, these are the bounds. Now we have about 1, 2, 3, 4, 5, 6, 7, 8, 9. About 9 states or 9 bounds. Now, if you look at this band is 1,100 to 1,199. There is about 62% chances that the system will be here. It will stay here. However, we have about 12% chances that it will move from here to this place. It will move from 1,100 to 1,199 bounds to 1,000 to 1,199. About 12% that it will transit from this state to this state. Then about 19% that it will transit from this band 1,100 to 1,199 to 1,200 to 1,299. Then about only 7% chances that it will transit from this loop, from this bound, from this beam 1100 to 1199 to 1300 to 1399, and that also applies to other bounds of state to state. This is what we call the network. And now this, we can know that the movement of the system from one state to another with relative ease. Now that is done. The next one that we are going to look at is to stack the area plot of forecast. Let me stack it and see. I will just tell chart to give me the code to plot the stack area plot of forecast 0 to 5. Now copy. Let me ask chart to give me the code. Ctrl V, enter. So I'm waiting to get the code from chart. Now the code has been supplied. Let me copy it. Copy. Then execute. Ctrl V and Shift enter. Now I have just error. Let me tell chart there is error, and I want him to fix the error. So let me just put the error here. So I'm expecting chart to fix the error for me. Okay. Now I think he has done that. I've done that. I copy, move back, Ctrl V, Shift enter. Good. Now this is the stacked area. What is the explanation of this? This simply means that the system has about 100% chances to remain in this price band. And what is this price band? This price band, this color is this is the color 1,500 to 1,499. It has 100% chances to be in this price band. So you spend more of the probability here, about 100%, but it will decline gradually. It will decline gradually. Then it has very little percent to jump up to this band 1,600 to 1,699. So now in S6 it has almost 100% bound to stay in what? In the band of 1,500 to 1,499. But after some time, it will reduce. Then it could jump to this band, but with very little probability. Then it can also go to this band of a little bit decline to this band, with also little probability. That is the band of 1,400 to 1,499. This higher bound, the chances is too meager, it's too small that it will move to 1,700 to 1,799 within this period of 5 days ahead. This is the explanation. If you need further explanation, please consult me. You can send me email message on my email address ajibola.arewa@lasu.edu.ng, or you send me WhatsApp message on this line 080 60 96 20 48. Then the next thing we are going to do is histogram of observed price states. Let's quickly do that. Histogram. You have this just copy. Let's see that. Copy to get the code to draw or to plug the histogram. Then I Ctrl V, enter it. Yes. Code to plot histogram of observed price states. Now the code has dropped. Let me execute it. Ctrl V, Shift Enter. Yeah, this is histogram. And you can see that price 1,500 to 1,499 has the highest frequency, almost 160, and that is followed by the band of 1,600 to 1,699. So within this 5 period, days ahead, or this 5 days ahead, there's tendency that the system will be between 1,500 and then 1,499 naira per dollar. Now I told you that I won't do number 8. That is the chord diagram. If you need that, please consult me. I will not do number 9 also. I will not do number 10. If you need all that, please consult me. Then let me move to number 11. Number 11. Number 11 is the actual price with the predicting parts. We want to know if the predicted part actually capture the actual prices. I want to know the reliability of this model. So what I will do, just copy this instruction and then execute it in a chart. So I will ask chart now, please just give me this code to draw the actual price against the predicting part. So I have the code here, so I copy it and then execute. Ctrl V, Shift Enter. Yes, I'm having an error. Let me just copy the error and tell chart that I have an error. So what can it do about that? So Ctrl V, I will enter. Let me see the result now. Okay. So full working block corrected. Let's see now. Okay, let me try this. Ctrl V, Shift Enter. Now we see that this diagram is not the right diagram because the part did not show, the actual part did not show. So what I will do now is that I will tell chart that the diagram is not the ideal diagram. This is not the ideal diagram. The part did not show. This is not, this is not the ideal diagram. The actual price, did not show. Please give me updated, please give me updated code to show the actual price along with the predicted paths. So we are looking at the actual along with the actual price and the predicted paths. Now, what I'm trying to do here is that I want to get the right code to get the right thing I want to do, the right code to do the right thing I want to do. So what he gave to me is not what we asked for. So let's see what we are going to have. Yes. Yes. Now, he said the update will do what? We plot the actual price as line. That is fine. Overlay the predicted price band using the midpoint of each price band. Fine. Display both series on the same chart using yes. Okay, that is what I want. Let's see what we are going to have. Copy. I hope it is copied. Let me just paste it here in the command section, then enter. Good. This is what we have. We have the predicted and the actual. So with this, you can see that the predicted is stable, very stable, and then the actual price declines a little bit. It declines a little bit, and then there is no intersection, meaning that the model does not really capture the price movement. It doesn't. Okay, having done that, if you need further questions, please you can consult me on this. So having done that, we move to the next one, which is a log run. Let's look at log run. Steady state. Let's forecast by the log. Let's forecast using the log run Markov chain to get the steady state probability distribution. So go to chart, Ctrl V, enter. I hope you know that we have done the short run in video 2. So we are now doing the log run forecast. Just like what we did in video 1, when we forecast using the log run method, and then we also forecast using the short run method manually. Now we are now using the Python application to do all of that. So let me copy and then paste. Ctrl V, Shift Enter. So this is what we have. This is what we have. And these are all the probability that the system will rest in each of these price bounds. If you add all this probability together, it should give you 1. It should give you 1. This is the probability that it will be in the initial state. This is the probability that it will be in this price band. That is 1,200 to 1,299. And this is the probability that it will be in this price band, very small, 1,700 to 1,799. This is the log run forecast. The next thing there is the stimulation. Let me quickly look at that. Stimulation. We have to stimulate. Give me the code to implement log run Markov chain stimulation. I want to stimulate now, and then I will just quickly go to chart to get the code to stimulate. I'm waiting for chart to crack the code for me. This time around it's taking time. However, if it takes much of this time, I may end the video here. Then you can practice it by yourself. So if you want to practice it, you just get the code and then you come to this place to paste. You can do it. So once they give you the code, once you put this instruction to chat, it will give you the code. Then you come here to implement it. Yes, I would say that video 3 will end here. And if you have any difficulty in practicing any of this, you can call on me. I will be of assistance to you. Consult me, and I will be available. Please, if you watch this video, subscribe to it, love it, and share it. Thank you very much for sparing your time to listen to me. My name is Dr. Ajibola Arewa. I am an expert in financial econometrics, financial modeling, and financial asset pricing. Thank you.